Good evening. Good evening. I will begin the session today. Today's session we want to move from remix. We have learning about Solidity smart contract first of all, and up to now we have created a simple smart contract using Remix IDE, the Remix environment, and I I told you guys that Remix is usually used to model the view that a blockchain is expected to have. So if you have uh, store functions and retrieve functions, the Remix IDE will help you simulate that. So it will help you see how a blockchain is expected to work, how a smart contract is expected to function. It clearly highlights the functionalities of a smart contract. So today we want to move from this environment that we have been using, and we want to go on to VS Code now. I know most of you are probably asking, when are we going to VS Code? So we now want to jump to VS Code, and just to make things clear, we have not yet completed learning Solidity. So this is the first project that we will do, and during our Saturday session, we will create another smart contract that is a simple token. We will see what functionalities are required for a token, and we will create a simple token, and then we will deploy them, or we will commit them to our GitHubs. So that will be the second project, and then from next week we are beginning a new project. So we are learning Solidity through projects. So that is just the way that I use for learning. That's just my way of learning through building this simple projects. So we now want to move this to the to Visual Studio, to VS Code now. So I have my VS Code open, and I want to. I already created a certain folder. Okay, this is one of the projects that I had worked on earlier, and using this, I am going to first of all, um, I need you guys to install WSL. If you don't have WSL Ubuntu, we need to install WSL. So to install WSL, we use the command WSL install / install. So WSL is basically a Windows Linux environment. It is Ubuntu. Basically, it is the Ubuntu environment, but under Windows. It is the Linux environment, but under Windows. So if you don't have it in your command prompt, then you basically just use the WSL / install. But I have it, so I don't know how long it will take, but you can download it. So since I have it, I won't download it. Instead, I will just call it, and as you see, um, it is supposed to change the color. This color, you will notice this is the PowerShell environment. So when we open WSL, you will notice that it will open WSL. Okay, there it is. Now you see, this is now the WSL terminal. We're using the bash terminal now. Now using this bash terminal, I will use the following commands. Don't worry about this. So these are just commands. Okay. These are just commands that we use to change the directory. So I need to open this directory. this is the directory that I have saved my um this is the directory where I have saved my folder. So my folder, I have a few folders here. So this is basically the location of my folder, and this is one folder, Foundry F23. This is where I store all my Solidity projects, this Foundry F23. And then under Foundry F23, I now have various projects that I have worked with. So the projects that the folder, these folders are for the projects that some of the projects that I have been able to work with. And the folder that we want is this project learning. So you don't have to go all through all this. What you can just basically do is open VS Code and then create a new folder, or you can create a new folder in your file system, and then once you create a new folder, you open it in VS Code, and then we will save our file in the folder. So it's not that difficult, but I used a different Windows environment to open a new Windows environment. So basically, when you go the manual way, my way is a bit complicated, but when you go the manual way, you can just create a folder and then you can open it from here. So when you click open folder, it will bring you to your file explorer, and then you can manually choose the folder wherever you created it. So don't it's not a must you use my way. My way is a bit complicated. But yeah, so we can open a folder. But since we are already on a folder, we don't need to open a folder. So what we'll do, we just need to exit here. It's not giving me the exit button. Okay. So you see, we are now in our folder, and our folder is empty. We don't have anything in our folder. So once you open your Solidity and environment, what you do is once you have installed your WSL environment, because remember I showed you that it's supposed to be in WSL, because some of these commands PowerShell cannot understand the commands. We will be using the terminal a lot in terms of deployment and interacting with our smart contract. So at times, some commands that we will use, uh, the PowerShell might not understand it. So we have to use Bash. And to use Bash, we have to install our WSL environment. If you have the Ubuntu or Linux, uh, if you have the Ubuntu or Linux machine, then you can look up how you can work with that. But I think if you have Ubuntu, most especially, then you're safe. You can simply just start your project. So what we will do after installing our WSL, make sure to install WSL. After installing WSL, we open you can open the folder that you created, then now you can install WSL in the folder, like in your terminal over here, like this. So we have remember me, I already have WSL, so I don't need to install it. It's such a long, it takes some time to install all the dependencies that you may need. It may take some time. So once you've installed WSL, you now install something that we call Foundry. So Foundry is a tool that we use with Solidity. So it is the tool that we use to, it has some libraries that Solidity needs. Foundry also, we use Foundry to test our smart contracts, to test their functionalities, whether our functions are actually working as they're supposed to work or not. So Foundry is a very important tool in Solidity smart contracts. Another version of Foundry is the hard hat. So if you don't want to use Foundry, you try out hard hat. Hard hat, basically they have the same functionalities, but hard hat is more traditional. Hard hat ni ya kitambo kidogo. Foundry is a bit modern. So What you'll do, you now install Foundry, and to install Foundry, you just state this command. But remember, this command you have to state it in while in the WSL environment. If you're not in a WSL environment, then it won't work because okay, let's just see. For example, let's open a new terminal. Let's open a new terminal, and I wanted this terminal to be an any. Okay, let's just go on. I can't open because you're already in the WSL environment. You can't open a PowerShell terminal. But the PowerShell terminal, probably if you try out typing forge in it in the PowerShell terminal, PowerShell will not understand the command forge. And that is why we use WSL. WSL is the environment that will understand some of the commands that we will use. So for forge, forge actually introduces Foundry. So forge is used to install Foundry into our machine. So forge init, then we run it. So after we run forge init, we realize that we have a few uh, things that pop up here. We have the lib, we have the script, src, test.git go, foundry.toml, and then the readme. As you can see, initialized forge project. So forge is a very important tool. It is a foundry tool that we use. It is a command. Forge is a command that we use to install foundry, or we use to interact with foundry. And foundry, as I said, is a tool. You can think of it as a framework. So once you install Forge init, you see this couple of files pop up here. You can notice the GitHub. So this is just the workflow, the GitHub workflow in case you post, you commit to your GitHub. This is the GitHub CLI, the one that checks the workflow. And for this, yours may probably not come like this at once. But what you need to do, you need to install an extension, a Solidity extension, so that okay. So let me show you something first. So you notice that when you drop down this lib, uh, it has a few files here. It has another scripts, src, test, git attributes, all that, all that. So this for the CD, this is actually a library. This is a Foundry library. So we will use this in various aspects in our code. And libraries are very important because remember we say that smart contracts on themselves by themselves are not intelligent. Smart contracts only have the functionalities that have been put in them by the owner. So a smart contract cannot interact with its environment fully. So that's why we have libraries. That's where libraries come in. Libraries help us interact with our smart contracts fully. Uh, they help us to run scripts. They help the smart contracts to fetch data from external files and all that. So this is the library, and we will see where we will use the library is called ForgeSD, and we will see where we will use the library. Just begin, and then this is the SRC. So once you install Forge Init, it automatically comes with this script. So scripts, I told you that smart contracts can be deployed using a script, and this is an example of a script. We also wrote an example of a script, but it was not fully a script, but it was a smart contract that deployed another smart contract. So that's what we call scripts. That's basically what we define to as script. But so yeah, when you install Forge in it is automatically supposed to bring you a script file, a source file, and a test file. So we will just delete this because we do not need them. But whenever you install Forge, just be sure that you will get. So let's delete them. Yeah. So remember in our previous sessions we talked about the first, and we said the SRC is where we keep our main code, our main code base, our main file, and then the test is where we will keep out the test. We will see this later on. So under SRC, we will create a new file, and our file, remember we called it storage contract. So let's so for we have to remember that when we are writing a Solidity file, we always have to add the .sol. That's uh, just like you need to add a .pdf to a PDF or a .png to a PNG file. This is also a Solidity file. So for the machine to understand that it is a Solidity file, you have to save it with the .sol extension. So in C++, it's .cpp. In C, I don't remember in C what it is, but in C++, it's .cpp. In in HTML, it's .html. You see, you always have to make sure that you save your file with the appropriate extension. So ours is storage contract. So what we will basically do, we will go to our our foundry, our remix IDE, and we will just copy this because we had already coded our storage contract. There is no need for us to start coding it again. So copy our we will copy our smart contract, and then we will paste it here in our yeah yeah we will paste it there. So at this point your smart contract may not be having all these. So what we need to do in order for us to work with Solidity, we also have to install a Solidity extension. In order for us to work with it in the VS Code environment, we have to install our Solidity extension. So you just come to this side and then you search Solidity. So you will pick this one by one blanco. Uh, Error while fetching extensions. Okay, so you sometimes you might try to maybe install Forge in it, and you encounter an error. Maybe it says git module. There's a number that it gives, git module something. So this is usually a problem with the internet. Okay, at least my machine has the problem. So what I usually do, I have to manually change my IP address, as in the IP address that is in the VS Code or that comes built with Foundry cannot access the internet. So I have to manually change that IP address so that it can reflect a server from Google, for example. So let me show you what I do. So I use the following command: sudo resolve.conf. So this actually took me some time to realize. You just input my sudo password, and then once this file opens, so the reason I'm doing this is because see this error here, it means that my Solidity is not connected to the internet, so it's not showing me extensions that are online. So I have to come to this file, and then I have to change, you see, name server. So I have to change this server. This is the server that the local WSL is using, and seems like the server does not have access to the internet. So what I come and do, I comment this out, the name server. So that when I input the hash there, actually add 1.1.1 and name server 8.8.8. So the name server 8.8.8, I know it's the IP address of a Google server. So with that, I think I can now I save you save using ctrl s or ctrl x, yeah, then you execute using ctrl x. So now when we come and refresh, let's refresh and see. Oh, there it is. At least you see now we have a lot. We have now the extensions coming, the online extensions showing. Let's wait. Let's give it a moment. But yeah, I just wanted to show you guys in case you have, I mean, in case your VS Code or your WSL, you've managed to install it, but it's not getting to, it's not get, it's not, it has not been connected to the internet. You have to change the IP address of the server. And yeah, I don't know why it's now not returning, but it's supposed to return the full list of all Solidity extensions. So the preferable one is this one by Yuan Blanco. Uh, Juan, however you read it, but that's the one we prefer. That's the most effective one. So once you've installed that, let's go back to our file. Okay, it is. So once you've installed that, we save, and yeah, that's it. Let's continue. So remember I we talked about script. We talked about something we call scripts. So scripts are basically programs that we use to execute certain commands. Uh, so scripts are usually used. Scripts are usually used whenever we don't want to deploy our contract directly. Actually, they are used most of the time because we have this storage contract, and we don't want to deploy it manually. We will use because once we deploy our project, our whole project, uh, we cannot alter anything inside the project. Remember, we said a Solidity smart contract is immutable. So it means we cannot change the details of the smart contract. It means there cannot there is no human intervention. So that is where scripts come in. Instead of if we want the smart contract to do a certain functionality after deployment, or to be doing certain functionalities after it has been deployed, and the functionalities cannot be added on the main storage, on the main contract, we input a script, we write a script. So the script is basically there to help us with uh, mostly it helps with deploying the contract, and then it helps us to deploy the script, the smart contract. But let us before we go to the script, let us first try and see how we can deploy uh, our smart contract. So what okay, we will first, before we go to script, we will first discuss how we can deploy the smart contract on the VS Code without using a script. First of all, let us first try the manual way, and then we now deploy using a script and see the difference. So we remember in Remix, it was not that difficult because we could just sorry. In Remix, it was not that difficult because we could just deploy from our Remix environment. So in the Remix environment, we just compile our file, then we come here and deploy. Then we can see the deploy construct here. So you can see whatever the functionality of the contract is here. So in the VS Code, it will be a little bit different. First of all, let's open a new bash, a new terminal, and we have to understand that when you install Forge, it also has a local blockchain environment, and this local blockchain environment is called Anvil. So Anvil is one of the, let's say, features that come when you install Foundry. So once you install Foundry, you have the access to Anvil, Chisel, and yeah, Anvil, Chisel, and of course Forge. So these are commands. So the Anvil command is used to instantiate to or to initialize instantiate. That word is difficult to pronounce. But Anvil is used to instantiate the local blockchain or to initialize or to start the local blockchain. So the local blockchain environment exists in our VS Code. So that is basically the, I don't know, should I call it, the it, yeah, it exists in the machine. It is a local blockchain. So it's not a test net or a true blockchain. It's just a local blockchain that we use to simulate development for development purposes. So when you press Anvil, when you type Anvil, and this is after you have downloaded your WSL. This is after you've downloaded your WSL, and also you've downloaded your Forge. So this is Anvil. Sorry about that. So this is Anvil, and Anvil is a local blockchain. And when you instantiate an instant, when you initialize an Anvil local blockchain, you get uh, you get an account. So you get 9 accounts, and these 9 accounts are each loaded with this is 10,000 each, but this is not real money. These are test nets. So each account is loaded with test nets, and each account has its uh, adjacent uh, private key. So for example, account one, the account zero has this private key, and account one, this is the private key of account one. Remember, we talked about private keys, public keys, and we say that private keys are the ones that are used to sign transactions. So if someone gets access to your private key, then that becomes an entirely different situation because private keys, when someone has a private key, they can actually access your wallet. They can access your wallet. They can sign transactions. So they can basically do whatever they want with your wallet. So the private key is like the security of your Web3 wallet or your blockchain wallet. So whenever you hear or whenever you sign up to a blockchain or Web3 application, sorry about that, whenever you sign up to a Web3 application and then you get a private key, and nowadays they come in form of seed phrases, they come in form of these private keys. So especially the seed phrases, projects like Pi and those who have worked with Pi, you have a seed phrase that you're given. If you lose your seed phrase of, or if someone gets a hold of your seed phrase, then automatically the person has access to your account. And if you lose your seed phrase, then that means that you've lost the access to that account. In blockchain, in crypto, there is no reverse. There is no forgot passphrase or key, private key. Once you've forgotten your private key, once you've forgotten your passphrase, that's it. It's lost totally. So whenever you're creating a Web3 or a blockchain wallet, always, always, always make sure to keep your private key in a safe place, number one, and keep it well so that you don't misplace it. Put it somewhere where you're sure you won't misplace it. There are uh, professional gadgets to do that nowadays, but I feel like they are a bit expensive. But you can also check on that if you can get one. So the traditional way of deploying, you come and then use there's a private key. So this was the command that was used to deploy using. So for deploy using VS Code directly. So first of all, you have to ensure that Anvil is active. So you use the following command. You remember I said forge is a command. So it's forge create. What's the name of our contract? Contract name is storage contract. Forge create storage contract. And then this is the most important part. RPC URL and HTTP. Uh, uh, oh yeah, HTTP and private key. Okay, so this is the format of the command that you're supposed to use. Forge create storage contract at PC URL, HTTP. So I want to uh, make you understand. So Forge create, these are of course inbuilt Foundry commands to that signify that you want to deploy your contract. Storage contract is definitely the name of your smart contract. That's the name of the smart contract. And then the RPC URL, RPC URL is still this HTTP. It's one thing. RPC, what does RPC mean? I forgot. What does RPC mean? So RPC URL and then private. So where will we get the RPC URL? We come back to our Anvil environment. First of all, the private keys are well listed here. And in case you see this mnemonic, this is what I was saying, the passphrase, the seed phrase. This is the seed phrase of this wallet. And then we have the chain ID. This is the local chain ID, 31337. This is the chain ID of the local blockchain. And then we have the gas limit. We have the Genesis number, which is this. This is the Genesis timestamp, Genesis number. That is the time that the Genesis number is the number of the first blockchain. So listening on 127. So this is the IP address of the local blockchain or the local, they call it server or the EVM. So that's the RPC URL of that. So what we will do, we will come forge create storage RPC. This where HTTP is after the forward slash. That's where we input, we copy paste our number. You see, That's why we input that number. And then here where the private key, we come back to Anvil, then we select one of the private keys. So I like to use number 5. So we use account number 5. So we copy that private key. Sorry, come on. We copy that private key. I don't want to copy the whole line. We copy that private key and then we come back to our bash and then space paste. Yeah, so once we paste, we can run the command to see what we get. And yeah, the compiler runs successfully. So we have managed to deploy our smart contract. So that's the way we deploy our smart contract, but we have deployed it to our local blockchain. So it's just in our machine to may deploy it to our local blockchain. That is one way of deploying, but this way it's not so advisable because you see we say that the private key should be as discreet as possible. It should be as secret as possible. So testing it on the terminal like this is not really advisable. It's not. So we want to find an easier way of uh, actually deploying our smart contract without pasting the private keys on the terminal. Because we say the private key is very sensitive, and in case you install a compromised extension in your VS Code, then that means that you will be vulnerable. So in case you paste the private key and your VS Code has been maybe has been compromised, then you're in trouble. And if your wallet has maybe you're holding a few bitcoins in there, then boy, do I have news for you. So, yeah, private keys should be kept private, just as the name suggests. So, the idea of us pasting our private keys in the terminal, hard pasting actually, is not a very good idea. So, though I want to simulate how when you deploy from VS Code, how it looks like. And this is basically how it looks like. So this is the input you get to, you see very large numbers over there. And then yeah, that's basically it. So we want to see how we can deploy uh we want to see how we can deploy without putting our private key in danger, right? Yeah. So first of all, let me check whether my guys showed up. Okay, we can move on. No problem. So first of all, we want to create a script. We want to create a script. We want to instead of uh, instead of deploying this way, instead of coming and then starting forge create storage contract, we want to try and deploy using a script. So what we do, we create a script file first of all. Come here, script file. Let's call it deploy storage contract. So yeah, yeah. So as you know, whenever you have a Solidity file, you always start with SVDX, license identifier, uh, then specify the license, that is MIT. Then we search the version of Pragma, Solidity. So I like using anything above 0.8.17. Yeah, so that's obviously we have to have that one in our we have to have that one in our website, in our Solidity file. Oh, let's add the sorry 17. Let me add that we have the semicolon. So since we are deploying the storage contract, we have to import it. And remember, we always use the import statement after the fragments. So Copilot is already helping me out here. So I like using named import. So I'll just name my import. And then yeah, I just use tab and Copilot is doing the magic. So first of all, the we install that, we import the contract, the storage contract itself that we want to deploy. And then after deploying that, after importing that, we first of all write contract, deploy storage contract, then open. So we have to have a function first. We have to have a function. And in our case, we will have a function run. So the function run will be an external function. So remember when we were talking about modifiers, or not modifiers, but visibility, we say that the external visibility is used to uh, read, they're used to access variables externally, only for functions. So only functions that are external can read this, uh, can see this function. So only external functions can call this function, can access this function. So function run external, then it returns. So the function returns the storage contract. Function returns storage contract. Then we open, and we we want to perform something. There is a VM start broadcast. So I don't want to talk about this right now, but we need to understand that whenever we are writing scripts, we have to use the VM start broadcast and VM stop broadcast. So whenever you have a VM stop broadcast, you always have a VM broadcast. So I don't want to talk about this now, but we will look at it later on. So there is something that I need to clarify. So one of the reasons that we have this library here is that when we need to write a script like this, we have to import one of the scripts. We have to import something from this library. So we will import the whole, we are supposed to import scripts.sol. So this is the script that's all. So this is like the let's say this is like the template of, or it is what will enable us to write the script. So these are libraries. It's like it's the script.sol file acts like a library that stores all the necessary equipments needed, all the necessary files that are needed to actually deploy from a script. So we will import the script from the lib, the forge.std. So we come back here, and then we have to import the script file so that our Solidity smart contract knows how to act. So we import the script file from forge.std. I hope it will start asking me for. Yeah, so we import from the forge.std. Yeah, so in our VM, in between our VM.broadcast and our stop.broadcast, we have to instantiate, or we have to initialize our contract. So remember, in our last lesson we talked about initialization of contracts, and this is how we actually do it. So new storage contract. So we instantiate a new contract instance, so that this is we talked about this when we were talking about deploying a smart contract from another smart contract. So there we were basically introducing the concept of scripting, and now in this case we are now creating an actual script. And so when you use this, when you this storage contract, remember this is the type storage contract. It is basically referencing to the storage contract itself, because it is a contract, so it is referencing to that type, the storage contract itself. And then the storage contract, this is the variable type. This is the type of variable, the variable type of the smart contract. And then this creates a new contract. So this instantiates a new contract instance. So that is basically a script, but we are not done yet. We have to add a return, because it's supposed to return something. We expect our function to return. So after the VM.broadcast, our function will return the simple storage, sorry, the storage contract. It will return the variable, and this is the variable, the storage contract, the variable. This is the contract itself, this is the variable, and then this is the new contract instance. Remember we said that new is a keyword that is used to show a new contract instance. It is used to instantiate or initialize a new contract instance. So we have a script. This is our script. Make sure to save ctrl s, save, always save your work. So that is our script. What's next? First of all, uh, we have a script. We let's check out this. So we have a few. Uh, we can check on the README. The README has a few notes on Foundry. So when you install, when you are, if in case you want to understand more about Foundry, or you can just check out README, or better off, you can just check out their documentation. The documentation is found here. Let's open it. So once you open Ctrl click, okay, it's not opening. Let's kata kufungua. Let's copy paste. Now we have to copy paste. So get foundry, that is get foundry.sh. Yeah, so that's basically this is the documentation of foundry. So in case you need anything, you see it has Forge. These are the tools. It has Forge. Anvil is the local Ethereum node with forking capabilities. You have Cast. This is the Swiss Army knife for chain interaction. You have the Chisel, Solidity, RPL for rapid prototyping and debugging. So we will mostly use Forge because it's used for building, testing, debugging, deploying, and verifying smart contracts. So we will mostly use Forge. So in case you want to know more about the smart contract, you can go and check out the Get Foundry research, and you will learn more about that. So let's move on. We want to store, or we want to deploy our. Okay, let's do this because I'm seeing time has gone. Let us end at that. That was introduction to VS Code and introduction and to Foundry and local deployment. So next time we will look at how we can deploy without necessarily having to paste our private key on the terminal like this. We will see, we will use a .env file and all that. So basically you can save the project, and I will meet you on Saturday. So on Saturday we will deploy this to our GitHub first before we complete it. We'll just deploy it to save it there. And then we will also go through we will create a simple token. So stay tuned guys, and have a lovely evening.